So last week, I know we have a few folks that are new to the class this week. So if you weren't here last week we covered modules 1 through 6. So this week we're picking up at module 7, which is the first big topic. I'm just going to divide it into two rough topics to make it easier. The first topic is probably going to be about an hour long, 45 minutes to an hour, and it's on the language basics. So if you've already been working with Genero BDL code and you're familiar with the syntax and some of the structures and statements, you can probably tune out part of that first topic or part of that first conversation. And then the second topic is on the generated code. So you may not be as familiar with the generated files, the 4GL files and XML files that BAM creates whenever we're working with generated code. So if you're familiar with Genero BDL already, you can kind of listen with half an ear for half the class today, and then maybe focus in again when we get to the part on the generated code, the templates. So it's a fairly long chapter. I think it's 44 slides. Some of those slides, of course, are just transitional slides and don't really have any content in them, but it's still a longer chapter than some of the ones we had last week. So I suspect that it will probably take us anywhere between an hour and a half to 2 hours, even though I'm going to move fairly quickly on this first set of topics here. You don't have to be an expert on the code. That's the whole idea of generating your apps. So I'm not going to spend a tremendous amount of time on the language and the language structure, this first topic, just because since we are using BAM, our application generator, to generate the code, we don't have to be coding experts to be able to create an application. So here's our learning objectives for today. First off, as I mentioned, we're going to look at the BDL language structure and syntax. We'll talk about functions, variables, records, interactive dialogue statements, and a few other things there. Presentation files, presentation style files, that's kind of hard to say. Top menus, toolbars. We talked briefly last week about resource files that we can use to have kind of global settings or application-wide settings for presentation styles, top menus, and so on. So this week we'll learn how to implement that. We'll learn more about these resource files today and tomorrow and be able to load a customized toolbar or top menu or presentation style in our custom code module tomorrow. So a lot of today's work is to prepare us for the custom code module tomorrow. Then the last part of the class, the last half, we'll talk about the code generation template, the template files that are out there. We'll look at some of those in detail today. We'll talk more about the code that's actually generated. We'll take a look at some of the 4GL source files that get generated by the template. And then we'll talk about the template libraries, the library files that are actually provided with the application generator. And you'll notice as we look at these generated source files that they call a lot of functions in these template libraries, so we'll see where that happens. All right, before we get started into the first big topic, do you have any questions or comments before I get started? Anything I need to know before we jump in this morning? Okay, just taking a minute to look at the chat interface and make sure I didn't miss any messages. All right, well, let's go ahead and look at this first topic. And as I mentioned earlier, I'll go through this fairly quickly. And the reason I am is because, remember, the whole idea here is that we're able to generate the code so we don't have to be experts with the code. We want to just get a general idea and feel for the language basics out here so that when we get into the custom code module, you'll have a better comfort level with that. You'll be able to identify some of the syntax we see. So Genero BDL conventions. First thing, BDL is just an acronym for Business Development Language. That's where we get the BDL. It's written as text in a source module, and our source module extension is .4GL. So all your source files for your BDL syntax is .4GL. You can use comments in your BDL programs. There's 2 or 3 ways to do it. You can use a pair of minus signs like you see here in the slide, or a hash symbol. If you have a lot of text or a lot of comments that you want to put in there, which is always nice for the programmers following you, you can use curly braces. So you can use those to delimit large areas of comments. That's easier than going through every line and putting in a couple of minus signs or a hash symbol, hashtag symbol. All white space in a source code module is just treated as a single space. So you can put as much white space in your application code as you like to make it more easily readable. It's not case sensitive. You'll notice that in a lot of our program examples that we do use uppercase a lot of times to just make it easier for you to tell what the keywords are and reserved words are in the language, but it's not mandatory. So BDL is not case sensitive, even though a lot of times in our samples it might look that way. That's just to make it easier for you to read. So our BDL program structure, you'll notice that the executable statements have to be grouped into program blocks. So we have a main block, and we'll take a look at that here in just a second, our main block for our generated code. And then we also have function blocks. So all of your executable statements have to be grouped within one or the other of those program blocks, either the main, all in the main, or you can separate it out into individual functions. Small programs, you could conceivably put everything in the main program block, but it would have to be pretty small to make that a comfortable thing to do. Typically, you'll break out some of your functions into separate program blocks like you see here in this example, and as your programs get bigger or your applications get larger, you might even find it convenient to put functions that are related, or functions that are related to doing something particular into modules together. And all of those functions then can be compiled and linked together to form your application. And that's what our generated code is doing. All of our functions are not all in the same source file. We've got multiple modules. In fact, we have a separate set of modules for every entity in our BA diagram, as we'll see here in a few minutes. Variables and constants. We'll just look at a few slides before we pop on over and look at these things. And that way we can look at several different things at once when we open up our application. So variables and constants. As you can probably guess, variables can hold values that are able to change over time. You can change those values programmatically. Before you can use variables in your application code, you have to declare them with a define statement. And I think last week we've already talked about the idea of being able to use this like keyword to declare a variable that has the same data type as a specified column in a database. We talked about that when we were discussing metaschemas and all the different purposes for a metaschema file. And this was one of them. The idea then, if we want to define a variable like a specific column in the database, it just goes and looks at our metaschema file to figure out what that data type and size is from looking at the schema. So here's a couple of examples of defining variables. Action no is being defined as a small int. We've got another example here of defining a variable like a column in the database table orders. So orders.userID. So it gets all the information about that column from the schema. Constants are very similar to variables, except that they aren't variable, right? They're constant values. They can't change. The program can't change them. They're static. The value can't be modified, and in fact, you can even leave off the data type and the size, all this information here, because it will get that information by the literal that you've assigned to it. So I could just say constant pi equal 3.1415926. So that's a constant. So that the data type information is actually optional with a constant. There's also structured variables in Genero. We've got arrays, and you're probably familiar with arrays. Even if you're not familiar with BDL, you've probably worked with them with other languages. An array can hold groups of items that are the same type. We have dynamic arrays and static arrays. As you can guess, static arrays have a defined and set size, and memory for that array structure is allocated when the variable is defined. And it can't grow, right? So if I define an array like we see here, has a static size of 100, then that's all the elements I'll be able to store in that array. It's not able to grow any further past 100 elements. But if I create a dynamic array, like this first example, it's able to grow, and it expands and extends memory as you add elements to it. So it's a more efficient way to work with arrays. Notice with arrays also, this one's a dynamic array of record, and it's being defined like a table in our database. So it's going to automatically, again from the schema file, pick up all the columns in that product table and define variables to match. We also have another type of structured variable, a record. So here's a simple record definition where we have explicitly defined all the members of the record. This one has two members, ID and name. Notice we have a define record and an end record as part of our syntax. And then notice even records, just like arrays and other types of variables, can be defined like a table in the database. And this one's automatically, with this .star extension, is automatically going to create a member in the record for each column in the account table. Now these are, I guess you could call them more complex data type structures. We have the idea here of being able to create your own special data type. They call them user types, and you can define the user type like you see here. This is pretty common based on table columns, but this time they're defining a special public type. We'll talk more about this keyword public here in just a moment. So think of it as just a special user type, give it a name, and notice here it's record in record, just like we saw with a record data type. But notice that we can define that however we like. So they're picking some columns from, it looks like the account table. So this one is based on a database, a couple of database columns, 2 or 3 in fact. And notice it's kind of a long record here, and they've got columns from multiple tables defined. So that's a fairly common thing to do, and you'll see that in the generated code as well. So that's referred to as a user type. The user or the generated code can create their own types to make it easier to work with the data. And then once you've got this type defined, you can just use it just like any other data type to define variables. So here this one's defining a variable mRecAccountLookup as one of these new types, RecAccountBR type. So from that point it's just a standard data type, just like the ones that are predefined. So the scope of a variable or constant can be local, modular, or global. Again, some familiar terms, so I'm moving pretty quickly here. So local variables can be defined in a function or main program block, but they're only known and usable within that program block. And you have to precede all the executable statements within the program block with your define, right? You have to define your variables at the top before any executable statements. Modular variables can be used in any function in a module. So they're across functions, or available across functions, but they are still localized to a single module. And in this case, the define has to appear at the top of the module before any program blocks. Now, global scope isn't as common, and I'll explain that more here in just a minute, but they are supported. You can have global variables which of course, just like they sound, they're available to any function in any module as long as it's the same application. And that can be defined in a global block declaration, or you can put them all together in a file, a special globals file, and import them into the application when they're needed. Globals are not considered to be a best practice anymore, these traditional types of global variables. Instead, it's moved off in more of a direction that's, I guess, more readable, it's more encapsulated within the application. Memory is handled better in this newer method that people use nowadays, and that's to use the public. So back here when we were talking about this special user type, notice it has the keyword public in front of it. That's more of a way to handle this idea of global scope, or a better way to handle it than the old traditional globals method. What you can do with these special public variables that you define is you can put those into a module and define them all together, similar in effect to a globals file. And then any module that needs access to one of those variables can access it by importing the module where those public variables are defined. So that's more the, I guess, the modern method of using a global scope for variables. So a lot of times you'll see these referred to, these public variables referred to in the documentation as global, but they're not specifically talking about a globals file, the old traditional method. They're talking about them being imported as public, as defined public. So more on that, public variables and importing the modules that those public variables are defined in. So the keyword import defines a dependency with an external module, and you'll see that a lot in the generated code. I'll point some of that out here in just a few minutes. All public elements of the external module can be shared when you use this import statement in a module that needs access to them. So it's not just variables. You can import a 4GL module, a Java class, a C extension library, and in addition to the variables in those different modules, you can also access functions that are declared as public. So it's not just variables. You can do the same thing with functions. So variables declared as public can be referenced by any other module in the same application that uses the import instruction. So here's an example, public type. Grab my highlighter real quick. Public type account BR type. Here's my record that's defined here. We saw this a few minutes ago when we were talking about defining these special user types. And then over here are importing modules that want access to that public user type can use the import statement at the top of the module. So notice here we can import FGL. That means it's a BDL module or FGL module. And then there's the name of the module. You can also, as it mentions up there in the text, the top part of the slide, you can also use those import statements to import Java classes and C extension libraries. We'll talk more about the C extension libraries today. We've got certain C extension libraries that are provided to the application generator and to you as a code developer that you can import the same way with this import statement. Passing variables. When you have variables and you're calling a function, you can pass a variable along when you invoke that function. So that's a fairly common thing to do in any language, I think. So the parameters can be variables, which is probably the most common, but you can also pass literals, constants, or even expressions when you invoke a function. You have to separate. If you have more than one parameter that you're passing, you separate them with commas. So here's a very simple program snippet here. So here's a main program block. Notice a comment up here. We're using the 2 dashes up here at the top for comments. Defining a phrase as a string variable. And I've got a short list of all of our different data types that are supported here in just a few minutes that we'll look at. Let a phrase equal hello world, so we're assigning a value to our a phrase variable, and then we're calling a function called sayIt, and then we're passing it a parameter, passing this a phrase as a parameter. And then down here is the function sayIt, so here it's accepting this parameter that we're passing in, and it's defining it here as sayIt phrase, and then all it's doing with that parameter is displaying it. Display sayIt phrase. Notice that display statement just displays, in this case, the value of this passed in parameter to standard out. So here's some of our BDL data types that we've been talking about, just to get a better feel for data types that are available. We have 2 or 3 different types of string data types. We have our traditional character or char. BDL understands either definition, so you can define something as a character with it all spelled out, or you can just define it as a char, and it will understand what you're talking about either way. So as you can see, a character type data type is a fixed size character string. And just a few things about character data types. In the older versions, the first thing I would say here is it's by default it's 1 byte, right? You define how many bytes long this character value is. The maximum size for a character is, I always get this one off, it's like 65,534. So the big question is it characters or bytes? And the answer is it depends. The default behavior with Genero Mobile is that it's 65,534 characters. And the reason that's the default with Genero Mobile is because a couple of environment settings. Genero supports byte length semantics, they call them, or character length semantics. And it just depends on your environment variable settings as to which one your application is going to use. So let me show you something real quick. This is probably just as good a time as any to go ahead and pop up and look at something. It doesn't really matter which one we look at. We'll use this one. Pop this over here so you can get a look. Last week we saw that you've got an option here where you can display your environment. It's not paying any attention to me yet here. Hello, wake up. One second. I think I've just got a bit of a delay here. It's ignoring me for the moment. It's not in focus. There we go. Now let's try it again. I think my operating system was busy on something else here. Let's try again. There we go. All right, so you've got this display environment option that shows you all your environment variables. We saw that last week. That's useful when you're troubleshooting or trying to figure out what settings you're using. So I'm just going to pop down here and show you a few of them, if I can find them today. Right here, up at the top, see this FGL length semantics equal char. So that's why I was saying that the default behavior depends on your character set that you're using. And notice here we're using UTF-8 is our character set that's been defined here. And UTF-8 supports character length semantics, which means that each, like if I have a character data type defined or character variable defined as 50 for the size, it's actually 50 characters. So for languages, for example, that are multi-byte or use multi-byte character sets, like, for example, Chinese, it may take more than 1 byte per character. So here, if I have a character variable defined as 50 characters, that literally means 50 characters. Even if they're multi-byte characters and it's using more than 50 bytes, that's still supported. So that's our default. We automatically handle characters that require more than 1 byte, so multi-byte character sets. Now that's all configured in your environment. So notice if we look at our locale, this is our Android, our x86 configuration set that we've been using for all of our class this last week or so. And we have a locale environment set, and that's where we can define our environment variables. Here's our whether or not we're wanting to use character or byte length semantics, and notice we're using character, and this is our lang environment variable is set to FGL UTF-8, which is UTF-8, the UTF-8 character set. So a little bit of an explanation there on more about how our character data types are handled. So it is fixed size, but it's a fixed number of characters, not necessarily bytes. And the same thing is true for varchar and string. Of course, varchars are just variable size character strings. Again, they still have that limitation of 65,534 characters, but strings, the last string data type that you see here, is dynamic and does not have a limited size. It's just operating system dependent. Is the size that you're restricted to. So very large. We've got several different date data types. We have dates that support simple calendar dates. We have a more precise date time data type that gets all the way from a year down to a fraction of a second if you need it to. And then we have an interval data type that holds time intervals. You can actually do math, for example, on a couple of date or date time data types, subtract a couple of dates, for example, and store the result in an interval data type. Anything that's related to a time span, like an age, for example, or a span of time. And then down here at the bottom we have one Boolean data type, just Boolean, and it holds the value 1 or 0, true or false. 1, of course, corresponds to true, and 0 corresponds to false. Some additional data types. I won't go through all of these in as much detail because there's so many of them, but you can see we have numeric data types. I would say any numeric required to satisfy even a scientist, right? We have very high precision decimals available. We've got very large integers, 8-byte signed integers, all the way down to what they call tiny int, which I think is the maximum number you can store. There's like 128 plus or minus, very small, 1 byte. We have high precision decimals, and then we have one available here for currency formatting that we're calling a money data type. And then we have 2 large data types, one for storing byte or binary type data like pictures, sound files, that type of thing. And then we have an additional one just for text, plain old text files or plain old text data. Okay, so this is probably a good place to stop and look at a few of these things that we've been talking about just briefly. It's already a good place to stop and talk about character length versus byte length semantics. That's a hard word for me to say. I probably mispronounced that, but you get the general idea. So this is also a good time to just look at a few of these things in the code that we've been talking about. This is the very simple application that I created last week when we were working through a few things in class. So let me just pop up the 4GL here. Oops, I grabbed the one I didn't want. Let me grab the main. We'll start with that one. So here's my app.4GL. In a generated code, that contains our main block. So there's our main that we talked about in this first topic. Down here is the end main. So there's our main program block. And in addition, you can see this one contains a couple of function blocks as well. So there's 2 or 3 functions here, even though it is a small application. Up here at the top, we've got a few of these import statements. This one's the import FGL, so we know that this is a BDL module that it's importing. This happens to be one of the library files, library modules provided for BAM. We'll talk a lot more about those today and tomorrow. This one we'll come back to a bit later on today, this import OS. So we'll come back to that. Here's our schema statement. So it's telling it wants to use the pool doctors meta schema file. So if I have any variables defined like a database column, it's going to get it from that pool doctor schema file. Here's an integer, a small int, a string. So we see a pretty good array of some of the things we've talked about. A couple of functions. So I've got some locally defined variables and some modular defined variables here. Modular here at the top, and then local ones here defined inside of the function. So there's our function. Notice these are public functions too. Remember the public keyword that we can use to be able to share these functions with other modules. Nothing else that's really exciting is jumping out at me. Here they're calling some functions, passing it some parameters, a couple of parameters separated with commas. And notice there's a lot of commenting going on, and for the most part they're using the dashes. 2 dashes are sufficient, but a lot of people use more than 2 dashes just to make it more readable. So that's what we're seeing here, lots of dashes. All right, that's probably good enough for what we've looked at so far. All right, so let's pop back into the PowerPoint here. And let's go on to these interactive dialogue statements. Interactive dialogue statements are just kind of overarching statements that substitute for a lot of lines of application code. So they're shortcuts. And they have a lot of built-in functionality to handle interaction with the user in the user interface. So there's several different ones. We'll take a look at all of the ones here that apply to Genero Mobile. We've got the menu statement that allows the user to pick from a list of actions. I think we saw several of those last week, so that's not new to you if you've been in class this week. We've got the construct statement that allows the user to create a query by example, they call it, put in search criteria into a form to do a search. We have display statements and display array to display the contents of an array. And then we've got an input statement that we can use to allow the user to add, update, or delete data so they can input values into a form. So 4 different interactive dialogue statements. And those are all used extensively in Genero Mobile. So here's an example of a simple menu statement. Our menu statement has a menu and an end menu, kind of similar to a function. We've got control blocks with with all of our interactive dialogue statements. We have control blocks so that we can manage what happens in that interactive dialogue statement. Gives us a lot of control while we're interacting with the user. And we can control the user a great deal with those control blocks and what they're allowed to do and when they're allowed to do it. And then these are on action statements. We talked a lot about actions and on action last week, so I won't go through all of that again today. But we talked about here's an action that we might have defined, for example, with a button. That was one of the ways we were defining the names of actions last week, were by naming buttons. We also use them in button edits. And then right down here are all the things we want to do when a user triggers an action by selecting a button or a menu option in this case. So these are called handlers or action handlers down here after the on action statement. And that, of course, is going to invoke something in the code, right? Call a function, for example, or display a message, or who knows what, right? But in any case, it's going to invoke something to do in the application. So here's another one, on action, open account, and here's all the things we want to do if the user triggers that action. Notice on action exit, one of the things we're doing is exiting the menu statement. So that's a way to exit the menu and go on to some other part of the code. So menus define a list of options, or actions is the proper term in Genero. Here's a construct or a construct, however you want to pronounce it, is fine. And we mentioned earlier that this lets a user enter search criteria. So here we're creating or building a construct, and in the construct statement we can specify exactly which fields, which columns of the table in this case, are being queried, or the construct is being created on, by specifying them with that on keyword. So the user is able to go in and put in search criteria in the user ID field, the first name field, and the last name field, and that will go ahead and build a select statement, essentially, to search for values in the database that match that user's search criteria. And here's display and display array. Allows the user to view and or select data. Well, I don't guess there's and or there. They can always view it, right? So it allows the user to view data and possibly select data, right, from a list, for example, like a list form. One of the reasons we talked about display array last week was because we were talking about Zoom forms. The whole purpose of a Zoom form, remember, is to allow the user to pick from a list that's been displayed with this display array statement. So here's display array, displaying it to a screen record that's been defined, and then again it has its own set of control blocks that can be used to control all the events before the data is displayed, before a row is displayed, and so on, or before the user moves to a row, and so on. And then finally, the input interactive dialog statement allows data entry. So an input statement is what we use to allow the user to input new rows into a table, or into the form to go into a table. This is what we use for modify. So input supports any kind of data entry type function. Notice that I don't have input array up here. On the previous slide I have display and display array, and in Genero BDL there's an input and input array. But the input array is not supported by Genero Mobile, so I've left that off of our slide today. But just FYI, there is such a thing, it's just that it's not supported with mobile. Alright, so there's the interactive dialogue statements, they call them. All the different ways that we can interact with the user inside the user interface. We have a short section here on built-in classes. Now built-in is just referring to the idea that the class is built into our runtime system. It just means that it's not provided as like a C extension library or anything of that nature that you would have to import. Instead, it's implemented inside the runtime system. So the classes and the methods for those packages that we supply are available in your application without doing anything special. So a built-in class, they all, of course, belongs to a package. We have three different packages. We have the base package, which contains classes that you can use to interface with programs, files, pipes, if you're familiar with that terminology, and so on. We have the UI package that contains classes that you can use to interact with the user interface, control and manage things like windows, forms, Even all of the labels and data fields that are displayed in the form are all manageable with classes and methods in the UI interface. And then finally, this OM package contains classes that let you read and write XML, manipulate objects in the abstract user interface tree, that type of thing. We won't talk about those very much. Classes from that package are not as commonly used anymore. Previously, in older versions of Genero, it was used a lot to do things like hide or show fields or enable, disable actions, that type of thing, by manipulating them in the AUI tree. But now we have additional methods with like the UI package that we can use for that without having to get down to quite such a low level like we do with the OM package. It's still used for some things. We don't have classes and methods for everything that you could do with this special OM package classes, but almost everything. So a class implements a set of methods to manage a specific domain, like a specific set of related items. And it's just giving you an example here. The base.application class provides methods that are all related to the program environment. And we'll see some examples of that. They're actually used in the generated code as well. Some of these methods are used there. So a quick look at the base package. The base package we mentioned in the previous page includes classes that we use to interface with programs, files, pipes, strings. I don't think I mentioned strings, but you can see there's classes here that just have to do with string handling and string manipulation, like parsing a file, for example, and finding all the pieces of string in that file and possibly putting them together into something, into another string, or creating a string from pieces from a file. But we've got this base.application class that provides an interface to the program, the channel class that we can, whoa, I grabbed the wrong thing here. Let me try that again. I didn't want a pen, I wanted a highlighter. There we go. Base.channel class that we can use to manipulate files or interface with pipes. There's the string buffer class and string tokenizer class that I mentioned you could use to manipulate strings, create new strings from pieces in a file that are separated with tokens, that type of thing. Type info that we can use to serialize variables. Typically would do something like that to exchange data with another module, for example, and then it gets parsed back out again on the other side. Probably not the correct term, but that's as close as I can get today. And here's an example of the base.application class. It's using this isMobile method. So if base.application is mobile, then display a message to the user, app is running on a mobile device. Now that isMobile is a method that is used in the generated code to see if an application is running in what they call standalone mode, or I guess you could say in development mode. Standalone mode meaning that the runtime is on the device itself. So that's what they mean by isMobile in this case. Is the app running on the device itself, or are we in development mode where it's running on a development machine and then just displaying to the mobile device? So that's what this is checking for. If it's running, if it's been deployed, the application has been deployed to the mobile device and the runtime is on the mobile device, then this is going to return a true. If we're in development mode, like we are this week, and the app is running on our development machine, then this will return a false. So just an idea of what you can do with some of these classes and methods. And you'll see this in the generated code in a bit. And this is the UI package. Notice it has several classes, and you can easily see just looking at them that these classes are all defined to allow you to interact with some part of the abstract user interface. Windows, combo boxes. There's even a special one for combo boxes, forms, interactive dialogues. There's a special UI.dialog that you can use to interface with even the interactive instructions in the program. So an example here of a use for the UI.interface. Grab my highlighter. Make sure I don't get the pen this time. Here's another piece taken partially from the generated code here. I used an example. If UI.interface.getFrontEndName, that's a method that's commonly used in the generated code to figure out whether or not the application is running on an iOS device, which would be GMI, or an Android device, which would be GMA. So it's first checking getFrontEndName to see if it's GMI or GMA, and then it might do something specific based on whether or not it's running on an Android device or an iOS device. Can show you an example of that real quick that's, I think, pretty interesting, just to kind of give us something interesting to look at in this chapter. Some of it's not as exciting as it could be. If we look at our main program block and our generated code, it does some initialization, has an initialization function here that goes out and does that. It checks to see right here if the front end name, using one of those UI.interface methods that we talked about just on the previous slide, get front end name equal GMI. Right, so it's checking there to see if it's running on an iOS device. So if it's running on an iOS device, it's checking then to see if it's running in standalone mode. Here's this base.application.isMobile. So it's checking there to see if we're in kind of development mode, right, and the application's still running on a development machine, or if the application is deployed and the runtime is on the device itself. If the runtime is on the device itself, then it's going to do some initialization. It's going to set up a read-writable directory on the iOS device and put the database in it, right? There's talking about our pool doctors database file, our SQLite database file, and down here it's using some other special methods that we haven't talked about yet. I'll get to those in just a few minutes. So I'll just kind of say here that it's using some special methods or functions from a C extension library that we provide to go out and create a directory on an iOS device and then copy our database file to that writable location. So I thought that might be interesting since we're talking about some kind of dull-looking methods here, but you can see that actually they play a big role sometimes in setting up these devices and getting them ready. So just a little excerpt from some of the code that we just saw there just to give you an idea how these can be used. Now UI.interface has a set of, I guess you could call them library modules that are provided with it that already have some built-in functions that you don't have to reinvent, right? You don't have to reinvent the wheel. And there's 4 different provided modules that you can invoke with this UI.interface class. So it's called UI.interface front call, and you specify in that front call the module, the library file that's provided. One of them is called mobile, as you can see here, and then you specify the function in that module, and then you specify parameters that are required for it. So we have 4 different modules that we use with Genero Mobile. There's standard, that includes functions that are available to all of our front ends, even desktop front ends, right? Not just mobile front ends. And then we have a special mobile front call module that kind of self-explanatory. It has front calls that are mobile for mobile devices, but it contains front call functions that are common to both iOS devices and Android devices. And then there's one specifically for Android that only contains the special front call functions for Android, and then a different one for iOS. So those are very specific to a particular platform. Now, underneath the covers with our generated code, we've talked a few times, and last week you modeled the maps device entity last week. And if you remember, all you had to do to generate the code for that maps entity was provide a relation. You created the entity, you provided a relation between a form and the device entity, and then you just configured a few properties on that relation. And that's all you had to do to get this device API functionality. So that's the really nice thing about BAM, is that it hides the complexity of having to know all there is to know about these APIs. But underneath the covers, BAM is using some, or calling some wrapper function in these libraries that we've talked about a few times. And in the libraries, these wrapper functions in the libraries are actually using these front calls. It's a couple of layers down, but underneath the covers, our BAM generated code eventually is using these front call methods that we see here. I'll show those to you a little later on. Most of the ones that we're using with our generated code come from the standard module and the mobile module. Now this is where we're going back, and I mentioned in the code a few minutes ago when we were looking at the example code, there was an import statement in there that said import OS. And I said, well, we haven't talked about that. We'll come back to it in a minute. Well, here we are. We're ready to talk about that. And what it's referring to is that we have some extension packages that are provided as C extension libraries. So to be able to use the functions and methods and whatnot in these extension packages, you do have to import them with the import statement. That's what we saw at the top of this application we were looking at, the myapp.4gl application. Up here at the top, there's our import statement, import OS, to import that special C extension library. So import OS, and just a minute ago we were looking and we saw that it's using some of these special methods from that C extension library to create a path and copy our database file to a writable subdirectory, a writable directory on an iOS device. So you can see it's using, making extensive use of the special methods included in that OS package. So there it is, os.path class is what we're seeing. Functions to manipulate files and directories. You can see that right away there in the main, the module that contains the main program block in our generated code. We also have another package called util. We do have some util usage in generated code as well. We'll come back to this one tomorrow when we talk about, actually not tomorrow, I guess we'll get to this on Friday, had to think about that, but on Friday we'll talk about synchronization, different ways to handle synchronization with a back-end database server. So we'll actually revisit the util package on Friday. And likewise for the COM utility package, it contains classes and methods associated with managing web services, and clients. So again, when we start talking about synchronization routines, we'll be revisiting methods associated with this COM utility package. So for an example, here's on action get path. And I just wrote a little short application here called os.path.pwd. is one of the methods in this OS package that you can use just to get your current path. Now one thing about all of these front calls that I forgot to mention, and for some reason that reminded me, let me go back for just a minute before I forget. All these front calls that we talked about, the standard, mobile, Android, and iOS front calls, those are actually executed on the front end itself. So in the case of mobile, that would be on the device itself. So these actually are invoking or calling using this native device API to run a procedure right there on the device. So I don't think I mentioned that earlier, but that's the idea there. Those are actually talking to the device, and the device itself is actually running these procedures. Okay, resource files. Last week we did talk about resource files some because we were talking about actions and action defaults. And one of the things we said was that action defaults can actually be stored, all of your special defaults that you want to use to decorate your actions, things like text and that type of thing, images associated with them, can be all centralized inside of a file. They call them resource files. Each type of resource file, the ones associated with action defaults, now we're talking about styles. We have resource files that you can use to define top menus and toolbars. All of them have their own special unique extension. So action defaults we saw last week has an extension of 4AD. Notice that styles files have an extension of 4ST, and as you can imagine, toolbars have a TB, a 4TB, and top menus have 4TM. So they all have a unique extension associated with them. But they all work in a similar fashion. The idea is that you can centralize all the attributes for a particular type of resource, like a presentation style that you want to use for all of your windows, or presentation styles for your forms, maybe standardized top menus, that type of thing. You can create a file, put all your settings that you want to use in the resource file, and then use that resource file instead of having to define all of these special attributes at the form level every time you open a new form. So it's a shortcut, and it's a good way to get a common look and feel across all your different forms or windows or whatever it happens to be in an application. So here we're talking specifically about presentation styles. And it's just saying elements in your abstract user interface can reference a style attribute, and then it inherits all the attribute values that are defined for that style. If you have elements that don't explicitly reference a style, then they use what's considered the global default. We've already talked about being able to define all of our presentation styles in a special resource file that ends with a .4st. And maybe we've discussed the idea that we already have one out there by default. So one of the things that you might have noticed whenever we were looking at the abstract user interface tree last week is that you can open that up when you're running an application, and you can select over on the left-hand side of that, you can look to see what style file or action default file you're using, and it will give you the path for it. And there's already one out there by default. Now we didn't see it because the Pool Doctors app doesn't use the default. It actually loads its own special styles file. But here's where the default is. Try to grab that again. It's in your template directory, and then in the template directory, which is buried way underneath the installation directory, the Genero Studio directory, I'll show it to you in just a moment. Finally, you get down to the template files, and there is a directory called styles. And if you open that up, there is your default, this dbapp.4st file. And that is your default style file for any project configured as a BAM mobile project. Now you can create your own style file, which is what the developers did with the Pool Doctors application. And you can override the default by creating a new one and just putting it out there in your resources directory in your project directory structure. And probably instead of talking about that, it would probably be better for me just to show it to you. So let me just show you real quick what I'm talking about. Pop this over here. And we'll just get a look at these. We'll just start back here. So this is my installation directory for Genero Mobile. It's Genero Mobile 1.1, so I've got 1_1. So if we go down there underneath GST, that's short for Genero Studio, which is our integrated development environment. Bin, source, and this AG stands for Application Generator, so I'm going to pop in there. And this is the beginnings of our template directory structure. So remember that when we generate code, it generates it using a special template. So here we are at the kind of the root node of our template directory structure. So right now with Genero Mobile 1.1, our template is currently this dbapp 3.2 set of files. So that's all a template really is a directory full of files. So here's our set of files. We'll be looking at these in more detail shortly after the break. But right here is the special styles file that we're talking about right now. So if I open that up, here are two default resource files. I know this 4AD is actually our action default resource file, but they didn't create a defaults directory. They just kind of lumped it in here with the styles file. So that's for action defaults for our mobile apps. It's defaults for our mobile apps. And here's our default styles file. So if we open that up, I'm just going to say open it up with Genero Mobile 1.1. Here it is, dbapp.4st, and you can see what the styles file looks like. You can see it's an XML file, and it has all these different styles, style names, like here's a global style, right? Doesn't have a specific name associated with it like window.main or window main2. So this is our global style. So if you open a window and you don't explicitly specify an attribute for the style that you want to use, then it uses this global window style, just a normal window. Now notice all these different types of windows. These are the two that are used by our mobile apps, or most commonly at least used by our mobile apps. This window.main dbapp, that's our normal window type. They're calling it just a typical window. These other attributes down here like this action panel position and ring menu position attribute don't seem to be really used at all for mobile applications. I've tinkered with those some and don't really see any difference between the settings for them. I'll look into that a little further and let you know for sure, but for what we're concerned with here, I would just say you can ignore those two, and typically it's the window type that you're interested in for Windows. And notice there's two basic window types that are used with Genero Mobile. We've got this main dbapp style that's used for normal Windows, and then notice there's a special one defined for Zoom forms, Zoom dbapp. And the difference here is the window type is defined with modal for the attribute value. Modal just means it's a window type that's going to be displayed on top of any other windows that are already showing. And that's the way a Zoom form works, right? When you user selects the Zoom option when he's in a form, that's going to bring up the Zoom form on top of his current form so that he can pick a value from the list. So that's a modal window. There's all kinds of styles, though. There's styles for just about everything you can think of, every type of object in the user interface. There's no way that I would be able to tell you all the different types of styles and all the different possible attributes for those styles. But happily, we do have documentation that does know all of this and can keep track of everything. So if I just do a search and look for things like maybe window styles. If I look for this window style attributes, you can see that that does have all the possible, and it's extensive, all the possible different attributes. And it's nice because it shows you the front ends where those attributes will work and which front ends they don't apply to. like GDC is our desktop client, HTML5, and then over here are two mobile clients, right, GMA and GMI. So you can see that a lot of these different window style attributes, which is what we're looking at, don't apply to mobile. No, 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 for a lot of them. But there's a great many of them. Right, so here I don't need to really worry about the ring menu position or the ring menu size. Those are not used, so I don't have to worry about those. There's a ring menu position. No. And you can see there's a lot of them. So that's where you would go. If you see different attributes or you're curious about different attributes, check out the different attributes they have for every different type of object in the user interface. Each one of them has its own explicit documentation that defines all the attributes, all the possible settings for those attributes. So I use that documentation quite a bit. Alright, so that's the default dbapp.4st. And remember where it is. It's buried way down here under the template. And when you're in development mode, it actually is going out there and getting this styles file and loading it. Now I mentioned you could override the default styles file, and you can. Probably the easiest way, there's several ways to do it, but the easiest way for me to do it is just to make a copy of the one here and then go ahead and put it in your resources directory. Like here's my resources directory in my sample project that we've been playing with in class, this demo directory. So notice in your directory structure there's a resources directory, and if I'll just put my styles file in here, I don't think I made a copy of it, but I should have. Let me just see. Nope, I didn't. Let me get rid of that. I had something else that was already still in there. But if I had made a copy of that dbapp.4st, what I could do was just put it in here in my resources directory. And now if I have a dbapp.4st, it's looking for that name, it will automatically load it from here in this resources directory instead of the one in the template directory structure. Now notice I could use a different name. Look at this, it's already in here by default, mystyles.4st. You can use a different name for your styles file than dbapp.4st, but if you do use a different name, you have to load your styles file in the application code. So I'm going to leave it at that for right now, because tomorrow we're going to be in our custom code chapter, our custom code module, and I'll show you how you load a resource file in the code and how you find the proper place in the code to do that in that chapter tomorrow. So we'll kind of leave resource files at that. You can create them, and if you don't want to have to do any custom coding at all you have to do is copy them, use the same name as the default, and put it in your resources directory. And it will automatically load that one instead of the one in the templates directory. Alright, so that's probably good for presentation styles. And here's the example of specifying a specific style in the code. So this is straight out of the application code. So here's an open window statement. Open window, form name with form, attributes, style equal. And last week we saw an incident of this NVL operator that says, okay, I've got two different parameters here. Use the first one, L window style, unless it's null, right? And if it's null, we're going to return the second one, main DB app. So this one's actually going to use a main DB app style file, right? If the L window style is null. Now the reason that that L window style is there is just for you to give you a way to customize which style file that you want to use. And again, we'll come back to that tomorrow. So this one's going to use main DB app. Did I say style file? Oops, I'm sorry. Excuse me. I got tangled up. I'm talking about too many things at once. Let me go back. This is specifying the style, not the file, the style from the file that you're going to use. let me correct myself right here. Main DB app. I got the two twisted up together. So it's specifying to use that one. So notice it named it by name. So instead of using the default window style at the top of the style file, it's going to use this one with this specific name from inside the loaded style file, this window.main_DB app. I beg your pardon. I got off on a roll and said the wrong thing. So like styles files, toolbars and top menu files can also be created as resource files instead of defining them right there in the form. So toolbar files, notice they're XML files. Toolbar and top menu files are both XML files. And you can just define all your toolbar items here. And you can also separate them with a separator to put a little space between them. Top menus, very similar. This is all of your top menu items. And for both of them, this name is an important part of the definition because that's the name that needs to tie back to the action name in the application code, or that is the name that ties back to the action in the code, in both cases, top menus and toolbars. Here's this UI.interface load toolbar method, and then there's a load top menu method that can be used to load the toolbars and top menus. So again, last week we talked about being able to define those right there in the form at the form level, but this is considered a more efficient way because we can do this and standardize across all forms this way, instead of having to go to each individual form and define these toolbars or top menus and try to make sure that we get them exactly the same. We want to make sure that our application forms, all of our different interfaces, have a similar look and feel, and this is an efficient way to do that. All right, just a page or so more and we'll go ahead and take our break, but I wanted to finish this first topic. So here is Genero file extensions. To give you an idea of some of these files we've been working with. So down here we'll start at the bottom with our source files. The forms that we've been working with end with either a for FDM for our generated mobile or managed forms for FDM, that would be our CRUD forms, for example, and then the for FDZ extensions are used for Zoom forms. So that's the difference between these two extensions. One is for Zoom, one is for CRUD forms. We still support text-based forms. So if you've been working with Genero and working with BDL and forms for a while, some people still prefer text-based forms where you go in and more or less create them by hand in text format. And those have a .per or per extension. Doesn't really matter. Anytime a form is compiled, it's compiled to XML and it's going to end up with a .42f extension. So that's our compiled files. Our 4GL source modules, this you're already aware of, end with a .4GL. We've talked about that a few times. And when they're compiled, they have a 42M. So those are your compiled individual modules, have a 42M extension on them. Then when the linking is done to build the application, our 42Fs and our 42Ms are linked to create an executable that ends with a .42R. So our actual runnables end with a .42R. So just a quick explanation of some of these file extensions that you'll see out there. I haven't talked here about some of the other files that are used with code generation. We've talked about them some already. We have our program files. Entities out there have their own special files. We'll look at those after the break. We have .code files that are created to hold user code. So if you've gone in and put in any custom code during the build process, that custom code is extracted and stored in a special file that ends with a .code extension. So I haven't put those in the special file extensions diagram here, but those are also there, and we'll take a look at those after the break. This last part is on the code generation template, and we'll talk about that, and of course, the generated files, the generated code files. So we've talked some about the code generation template set already. We know that Genero Studio provides a standard template. We saw earlier when we were exploring that directory structure, looking for the styles file before the break, that underneath the directory structure there was two different directories for templates. One of them was the DBApp 3.1 template directory, and then right next to that was the DBApp 3.2 template directory. So these standard templates evolve with the different releases of Genero Mobile, and of course they make improvements to them and make changes to them every time there's a new release. So the standard template for Genero Mobile 1.1 is this DBApp 3.2 template that we saw before the break. So it has had some enhancements and changes since the Genero Mobile 1.0 release a while back. So DBApp 3.1 goes with Genero Mobile 1.0, and now we have this DBApp 3.2 template for Genero Mobile 1.1. Also, there is a template developer guide in our documentation. If you feel inspired or you get tired, let's say, of going in and adding, let's say, the same custom code over and over again with your applications, you can actually go in and modify the template files. You make your own copy of the template files just like you would a resource file, and then you can make changes to them to customize for your own environment. So that's perfectly okay, and we provide a developer guide to help you out with that. So here's a few of the template files. Again, we don't want to get too far into it here because you have a lab where you'll get to explore some of these template files. So we don't want to do everything here. But here's this creatables.conf file that has your file new menu options defined, just to give you an idea how all this works. Here's another, the settings.agconf has a XML doc to manage all the properties for all the types of BA diagrams. So that's where all those properties are defined that you see in the individual diagrams in the BA diagram, or the individual entities in the BA diagram, and the relations as well. So that's where those are all defined. And in your lab, you'll actually go through and look at almost everything here, at least discuss everything that you see here in the template directory structure. So I hope you take the time to do that lab this afternoon. We talked about code generation some in the overview chapter last Monday, over a week ago. We talked about how code is generated. So the idea of data consolidation, we have these BA diagram entities that we've gone through and configured, and we've worked with the properties on those diagrams. And part of the build process and the code generation process is to take all that input from those properties and entities that we have created and tweaked and create an XML file. This XML file, you can see that sitting out there. Every entity, here I'm clicking on this one here for our form in my simple application that we set up last week to explore some of the concepts. But if you look, the XML file has all these different properties in there. All the tweaking and tuning you've done to your properties is documented here in this XML file, in addition to all the information too from the schema. So a lot of information here, and all of this is used as part of the code generation process. So that's the XML file that they're referring to here. This input from the BA diagram is gathered into an XML file. And then when the code generation starts, that XML file and then the code template, all those files out there that we have are used to generate the actual application code. We went through these steps last week, so I'll kind of step through them fairly quickly today. If you remember from last Monday, the build rules for code generation, first thing they do is if you've added any custom code to the special areas in the generated files that support that, we'll talk more about that tomorrow in our custom code chapter, all of that code, that custom code, is extracted and stored in a special file. And each entity has its own special file. It ends with a .code extension. So when you see those out there in your source directory, that represents any custom code that's been added by you to your generated code. So it saves all of that out, it extracts that out, generates new source files from the XML file and all the information that you've populated in the BA diagram that's in that XML file with the template, using the build rules that we'll look at again here in a second, and it creates new source files, new 4GL files. When it's finished with that, it restores the contents of these special .code files back into the generated files in these special areas of the code that we're going to look at more tomorrow, and then it compiles them and links them. So that's the basic walkthrough of how the actual code is generated. Here's the build rules for code generation. If you remember from last week, I know most of you were here last week. I'll just pop in there quickly so you can see the build rules for those. But if you will right-click on your application node in your project, once again, my system's busy, so it may be, there we go, it came right back. And I look at this Edit Build Rules menu option. Then you can see the build rules and look at them in detail. And notice you've got build rules for a lot of things, but here's the one for the program entity, and you can see all the command lines for the build. This generate with the dash code in it that you see here, this first line of command line, grab a highlighter so you can tell what I'm pointing at. This is the part that goes in and extracts the user custom code from the files and saves it off to a .code file. So you can see that there. Notice that you've got different rules for different entities, right? Slightly different differences in the build rules for everything. Also has in addition to the command lines that are used to generate the source code files, it also has information in the rules for what the output files are supposed to be named, right? They're going to have these 42M extensions on all of our source code, compiled source code modules. Intermediate files, remember the XML file is used along with the .4GL source files to generate the final file, and then any additional dependencies are used. So there's the build rules. You decide to go out and look at them. We talked about, kind of looked at them all here. The part here that pulls out well, this first part, we didn't see that a second ago, but the first part here is the part that's generating the XML file, that generate statement. And this is the line that pulls out the code. Here is the TCL or TCL executable that generates or creates the generated code. This part down here actually goes out, and once the files, the source code files, are regenerated, this is the part that takes the extracted custom code and restores it to those files. And then down here you've got your final compile and then moving those to the target directory, your bin directory, for example. So you can read those build rules. You can even edit them if you feel inclined to edit them. Most of the time, though, that's not really necessary. Those build rules are pretty well defined for most users. So let's take a look here at the generated source files that we get from this build process. And you can see that if you look in the right side here at this flow diagram, that there's a lot of individual entities or source code modules created for each entity. These are all individual entities, well, except these two. These two up here are just for the database. But these other 1, 2, 3, 4, 5 files are all generated for the entities in the BA diagram. So there's, again, each entity has its own XML file, and then there will be additional 4GL source files. There's not as many source files for the program entity as there are for the different form entities. They're the ones that have most of the special source code files. But we'll take a look at all of those here in the lab, and today I'll go through them some briefly with you. So the first one to look at is the program.4gl file. So program being whatever the name of your program is, right? So that part, you substitute the name of your program. So the program.4gl file contains the main block that we talked about in the last topic. It connects to the data source with the connect to statement, and the data source, of course, is our Pool Doctors SQLite database in our case. Loads styles, action defaults, and then performs some initialization tasks. If you remember earlier, we took a look at some of the initialization tasks that it does perform. One of them was for iOS devices. Remember that it went out and created a writable directory for the Pool Doctors database. And it did all of that automatically. That wasn't custom code. That's just our generated code is smart enough to do that for iOS devices. So that's all things that you'll find in the program, whatever your program name is, .4gl file. So one of the things I wanted to show you today, and this is a good way to do it, get rid of all of this, styles, files that we were looking at before the break, is to use the debugger. That's one of the easiest ways to explore application code, especially if it's unfamiliar application code, is to use the interactive debugger that's built in as a component of Genero Studio. So since that's what we're trying to do here is explore some of this generated code, some of these special modules, let's just use the debugger to do it. So we'll start out here. When you use the debugger, if you're not familiar with it, this is a good way to hear about it and use it. We'll go in here and start out with this program file. And our program is my app, so our program file that has the main block in it is going to be called myapp.4gl. So I have that open here. I've double-clicked it there in the project view on the left, and it opens it up here in Code Editor. And I had decided to do that this morning, so I've already gone in and created what's called a breakpoint in the file. And what that does is when I start up the debugger, it's going to stop here at this first breakpoint to give me a chance to examine the code before it moves on and does something else. So this lets me stop it wherever I want to first stop it so that I can step through the program line by line or bigger steps if I choose. So now that I have a breakpoint, you need at least one breakpoint typically. You don't have to. If I didn't have this breakpoint here, what it would do is go ahead and continue on until it reaches one of the interactive dialog statements, like a display array, for example. And it's going to stop there because it's waiting for user interaction with that display array. And when it stops at one of the interactive dialog statements, I can hit the interrupt, which I'll show you in just a minute when we get the debugger going. But I do have this breakpoint, so let's go ahead and I can either right-click here on my application node and specify debug here, or I can use the debug symbol in the toolbar. Either one. So I'm going to hit it here. And there it's started up. And when it starts up, notice it's already hit my first breakpoint there. That's what you call that red dot in the gutter of Code Editor is a breakpoint. And it's giving me some of these special views that the debugger has that help me explore the code or debug the code. The one that I'm looking at here by default, I'll get my highlighter just to give you a quick tour. This area right here, right now, is the data view. So this is where all my variables are shown. These are variables from the application that are in scope right now. So these variables can change as you move on in the application and step through the lines of code because they come in and out of scope. So you're seeing the ones that are in scope. Over here, I have to get out of my highlighter for just a minute to switch. Here's the watch points area. Now I don't have any watch points, but what you can do with watch points is if you have let's say, a variable that you're interested in catching when it changes, and sometimes especially if you're debugging, you are interested in that type of thing, you can set that as a watch point when it changes values. And then it will act just like a breakpoint at that point. As soon as it changes values, then your program will stop so that you can examine those lines of code in more detail, whatever caused that variable to change value. So that's what a watch point is. I probably won't use watch points today, but that's the reason for them. And then the breakpoints are just these arbitrary places in the code where I have set breakpoints this morning so that we can see step by step when these modules are calling functions in other modules or doing something otherwise significant. So that's typically what you do when you're debugging. You'll go through and you'll find a place that looks interesting that you need to follow up on, so you can just set a breakpoint there, and then next time it comes around and enters that area again, or if you restart the application, it'll cause it to stop there next time. You can look at your variables more closely while you're sitting right there at that spot in the code. Okay, so back to our main or my app in this case, .4gl. So here's our main block, which is where I put my first breakpoint so that we can see what's going on. Now over here is another view that's pretty interesting, and I follow this one pretty closely, the backtrace view on the far right. That backtrace view tells me what function and what file, what source code module that I'm currently in as I'm tracing through the application. So of course right now we're just in the main program area where the main block is, myapp.4gl. And as we call functions, and those functions are in additional or external modules, we'll see that here in this backtrace view so that we can follow our steps or keep track of our steps. The only other view that I'll point out while I'm in here with this highlighter going is this command view. So you can notice up here at the top this FGLDB area that stands for debugger. I can actually type in the commands here. This is the command prompt essentially, except we're here in Studio. So I can type in commands, but since I'm just using the toolbar and commands from the right-click menu, which I can use as well, I'm not going to use the command line interface that much, probably not at all, but it'll show you what commands I'm using from the toolbar down here in this command line area. So that might be interesting to you to kind of keep an eye on that. Okay, so here we are in the main block. Let's just use this first area in the toolbar. This first icon in the toolbar is next, so I can show you step through the code basically one line at a time here. So here's the first function call myappinstall, and we've already looked at that. That was the part that went out and created the writable directory for iOS devices and copies the Pool Doctors database into it. But just to show you how this part works, if I want to walk into or step into that function so I can see the lines of code being executed, I do that with the Step Into icon. So I can just click Step Into here, and notice now I'm in this function, public function, myappinstall, and I'm at the first line of executable code. So here I am in the first line of executable code in this myappinstall function, and we've already talked about this in pretty good detail, so I'm not going to spend a lot of time in it. I'm just going to hit this next option over here, the continue icon, and that just goes on until it either gets to an interactive dialog or it gets to another breakpoint, whichever comes first. Let's see what happens. So what came first was another breakpoint that I put in this morning. So here we are, we're still in myapp.4gl, that's our current source code module. I can see that down here in the backtrace view. I'm on line 110 of myapp.4gl sitting at this function, myapp_open_first_form. So here it's calling another function, form UI open form. Now the reason I put a breakpoint there is because this is the first time that we're actually making a function call that's going to put us into a separate source code module. So I'm going to step into that module with this Step Into icon. And notice when I do that in the debugger that it automatically opened up this module for me. You can see it up here at the top of Code Editor, form1_UI.4gl. I can also see it down here in my backtrace view. Notice now I'm in Form 1 UI.4GL at line 37, sitting at the top of this function, UI Open Form function. So let's go back real quick to our PowerPoints. And here we were talking about the program.4GL file and seeing some of the things it did to it. We were kind of in the middle of all that, and our program is calling another module, a function in another module. So it happens to be this form UI.4GL file. So that's what we're looking at here. So let's see what this module does. It says it contains functions called from main, which is why we're looking at it right now in our source code, opens the form based on the open mode that you've configured in your entity properties. Remember that from last week? This might require us to jog our memories some because it seems like it's been a long time since last week. But if you remember, one of the things that we defined for our entities was the open mode. That was some of the properties that we were configuring with the different modes. So the open mode determines what mode the form's going to be in when it's initially opened. Typically the default is display, but we can configure that, if you remember, on the form entity itself, and that's the overall functionality for that form. That's the open mode. But remember, we can also override it in the relation. So just to kind of pop back in and look at that, just a quick review from last week. If we look at our entity, get this over here where you can see it better. Rats. That did not do what I wanted it to do. Well, phooey, we're going to have to come back to it because with the debugger in effect, it's not letting me look at everything at once. So we'll just have to come back and review that part in a bit. So never mind that part. But if you remember from last week, we talked about that open mode. We set that for the form entity itself, but then we can override that at the relation level. Just a quick review from last week. So right here in the application code, that's been taken into account when the code was generated, so it's now going to open that form based on those properties that we set in our BA diagram. So this is all in Form UI. So it launches functions to manage application states. It calls menu or dialog statements for the various states. Calls functions in another module, the form name UI dialog data.4GL, and form UI dialog.4GL to retrieve that data and manage subdialogues that do things like display the data, for example. So let's go back to our application and kind of continue along. So here we are now. We're getting ready. Get out of that and go back to where we were a minute ago before I decided to try to show you those properties. So here we are sitting at this function call so that we're going to be looking at form1_UI.4GL. So that's where we are here. If you look at the top and look at your backtrace view. So here's a function, just to kind of walk through and see what that function's doing here. We'll just kind of hit the high notes. Here it's getting ready to call another function to open the form, and it's getting ready to start fetching data. Right, it's getting ready to create a where relation and create a select statement to retrieve data. So we can step into that function if we want to. Take a look at it more closely. Now we're sitting inside that function, right at the entry point for the function. And here's the part where it's actually opening that form, as we read in our PowerPoint slide just a minute ago. So this module is going to open the form. Here's the style that it's using from our main, from our dbapp.4st styles file, and this is the main_dbapp style from that file. That's a mouthful. So here we are opening the form. It's going to call another function in order to get the default UI settings, all those different properties now that are part of our application from the properties we set in the BA diagram. It's going to get information about all of those. Merge those with defaults. And then here's going through checking to see, now this is a different isMobile function than the one we talked about earlier. That's one of the special class methods. This is a library function that's just checking to see if it's an iOS device or a GMA device. So this is actually different than the isMobile method that we talked about earlier today. So they're not the same thing. So it's just looking to see if it's one or the other. And then here is putting together a where clause. I'm going to go back to the data view over here so you can see better. So here's just creating a where clause. Nothing too terrifically exciting happening yet. There's checking the open mode, all the different settings in our properties to determine what it should do next. And here I've got another breakpoint because it's getting ready to call a function in another module, Form 1 UI dialog data. So let's go ahead and step into that so we can see that function. And notice it opened another module. So here we are now in Form 1 UI dialog data.4gl. And if we pop back into our PowerPoints here for just a minute, and we'll keep kind of walking through to keep up. There it is. I went past it. Sorry about that. So here's the information about this UI dialog data.4gl file that we're currently sitting in. So it defines modular variables. It's responsible for managing user interface data, like clearing variables, like records, fetching data, setting default values, that type of thing. But it actually calls functions in another module, Form UI data, to actually perform the select statements. So these modules interact with each other quite a lot in order to fetch the actual data, do all the setup of all the correct properties, putting all the action states in place that you've defined in all of your different properties. So there's a lot of interaction between them to do these steps. So now we're in this Form UI dialog data. And we see here what it's supposed to do. So we'll go back and see where we're headed. You can see that it's working on the where clause. If you're kind of keeping one eye on this data area down here, you can see the where clause is getting formed. Here's calling another function. Again, trying to get the where clause just right. Get data by key. And notice to do this part, we're moving off again to this UI data module. So we're going to switch into it. I'm going to step in so you can see that pop open. And now we're sitting in a function in Form1 _ UI data.4gl. So if we pop back into our PowerPoint and see what this Form UI data is supposed to do, it includes functions to retrieve and manage database data, which is where we're at right now. We have our where clause pretty well defined, I think, at this point. Defines records for database columns and tables so that we have somewhere to put this data when we fetch it from the database. Creates and fills that dynamic row of data and a dynamic row of record keys, and then uses SQL to select, update, and delete rows in the database, and handles SQL transactions. So these are all functions of this particular module that we're in right now. Doesn't mean that it's going to do all these functions right now. It just means that it has the capability to do all these things depending on where you're at and what you're doing in the application. So that's where we're at now. Is in this Form 1 UI data. So notice we've kind of come a long way in the process here. So here we are back in Form UI dialog data because that was able to go ahead and retrieve the information, and now we're after detail information, it looks like. I was a little ahead of myself. Now we're after the detail record information. Trying to skip by some of this that's not too terribly exciting. And then here we're back in Form UI display. So we're getting ready to do our display statement. And here finally we're sitting at a dialog, which I want to make sure I didn't miss that dialog, so I've been creeping along. So here is a dialog that's been defined. This is a procedural dialog statement that has a sub-dialog defined. And I think we saw that that's one of the functions of this Form 1 UI.4GL module is the sub-dialogs. Let's see, backtrack a little bit. Yes, contains dialogues to manage record, display, input, and construct. So that's what we're seeing here is we're in there looking at a dialog, in this case just to display because that's our open mode for our form. So there's our dialog, and in here if we're looking, we've opened our form, opened our window, displayed our form. We're sitting there still waiting for some information, so I'm just going to kind of let it roll along a little bit faster here since we've seen most of the modules now. All right. And so now we're sitting there waiting. This is how far I wanted to go. So I mentioned that it would stop at a breakpoint or at an interactive dialogue. It would have stopped in here in any case because it's waiting now for some input from the user. So at this point I have my menu options here to modify, delete, append, and next, and so on. So this would take us off somewhere else in the code. If I were to click modify at this point, now it's going to go somewhere else in the code based on options that I've selected. And I can see that here I'm sitting at a different dialog. So I think that's a pretty good start. I don't want to go too much detail because you have a lab where you're going to track through these different files and see what each module does. But just hitting the high point though, we don't get into it in too much gruesome detail. You don't really need to know that much detail typically to be able to find the right locations to add any custom code that you want to add. Tomorrow we'll talk about that in detail and you'll see that it's pretty straightforward. If you decide that you need to add some custom code for one of the reasons we talk about tomorrow, it's a fairly simple matter to find the right place. So you don't really need to know that much about the step-by-step in these generated files. So I think that's probably adequate. So we've talked about all of these. I think these are the only two we haven't discussed, so we'll kind of wrap these up here. The generated files for the database, there's one that's the name of the schema underscore dbxdata.4gl that manages the actual low-level select, insert, update, and delete statements to update the actual database. And then we've got another file, another source file, schema underscore dbxconstraints.4gl that manages your table and column constraints, checks those and makes sure that those constraints are in place. So all those different properties that you've set in your meta schema are kind of created in this dbxconstraints.4gl file. And that ensures that they're in place. Library files. We've referred to these library files a few times. Now these are library files located underneath the template directory structure that we looked at a few minutes ago when we were looking for the default styles file. Well, these are located in that directory structure as well. You can see there's several library files, and each one, of course, has a different set of functions that have commonalities. Like libdbappcore.4gl has common functions for managing errors in strings. libdbappexternal, EXT, has functions for managing interaction with mobile device peripherals. and that's the one that actually has the wrapper functions we talked about that are wrappers for those front calls that are used to interact with the device APIs. LiveDBAppFormUI.4GL has functions related to form transitions and states. LiveSQL.4GL has functions related to SQL transactions, errors, and database statements. And LiveDBAppUI.4GL has functions related to things like top menus, toolbars, and front-end type. So there's the library files. You'll see those if you perform your lab this afternoon. One of the things you'll do is go look at those library files. So that takes care of the PowerPoints for today. Let's just take just a moment here. I'm going to go ahead and kill this and take a look at your lab. The lab overview will be fairly quick because there's only a few parts to the lab today. Pop up here to the top of it. The first exercise is to gather information about the code generation template. So you'll learn how to tell from the environment variables what template you're using. And then you're going to explore the template files in exercise 2. Go check some of those out, including the library files. In exercise 3, you'll examine the code generation process. Now, one of the ways you can do that is to set verbose mode for the compiler. So I'm going to have you do that, and then you can build the project and go out there and look at more details about the build process when you do that. So that's what we're doing here. And finally, in exercise 4, you're going to explore the generated code more like we just did. You don't have to use the debugger. You can use it if you like. It might be kind of a fun way to learn how to use the debugger. And just explore the generated code with or without the debugger. So this is designed for people that are not using the debugger because it gives you instructions on how to open the proper file and that type of thing. But you're welcome to use the debugger if you like. So that's what this is, just exploring and walking through the code to see how the modules react and relate to each other. And that's it. A fairly short lab today.